team, send me one person. Okay, you've been through this before. We're doing gallery style. So you will grab enough of those for everybody on your team and dry erase markers if you're evaluating first. Okay, and you know how this works? These teams 2, 4, 5, 6, and 8 are presenting, and then the teams right below 1, 3, oh, me, and then 7 and 9 are gonna be evaluating, and then we'll just rotate to a higher number. We have 2 guest panelists, Dr. Marshall, it's right there. She's from UTeach, and before that life, she was a higher energy, middle energy, somewhat high energy physics. That's funny, I'm low. I was smaller physics. And this is Dr. Walker. She's also from UTeach. Yay. And before her life as a high school chemistry teacher, she was a biochemist. So do your best, project confidence. Also, they are so grateful that you allowed them to film this entire project that they have brought you Tiffany's treats. Have you ever heard of that? No. Cookies from a very nice place. So we'll have cookies after we're done. Yay. Yay. He should be here soon. So bring up all your stuff. I'm gonna give you like 5 minutes so we can get started so we have more time for cookies after.
Third period. In order for me to grade any last minute things, I need all of your documents either shared if they're Google Docs or in the shared drive if they are, for example, PowerPoints or your Sketchpad files by 5 o'clock today. So whatever's in there at 5 o'clock, that's what gets graded. Don't email me things over the weekend. Put it in the share folder.
Okay, go to the team you're evaluating. Team 1, go by team 2. Team 3, go by team 4. I will go to team 5. Team 7, get over to 6. What is the haplozone?
Okay, the haplozone is where liquid water gets not planet, like the zone around a sun.
So do you have your orbits up? Because the second part of the question is to explain what happens to a planet just based on that. Okay, continue, Connor. Pick a planet and explain what's happening to that planet.
First I'll start with Earth, our Earth-like planet. It's right in the haplozone. It's right next to, therefore liquid water can exist on its surface. Our next planet is Earth, which goes through the haplozone and gets too close to its stars, so the water boils, and then it gets too far out where the water freezes. Therefore, no life can exist.
Okay, Stephen. How do mass and distance affect the gravitational force between 2 objects?
The larger the mass, the stronger the attraction would be. And 2, the smaller the mass, the attraction would not be as strong. And the closer the distance is, the stronger the attraction would be. The further the distance is, the weaker the attraction would be.
Okay, Michael. What is scientific notation? Give an example of a problem that's easier to solve using scientific notation.
Scientific notation is the way to simplify very large numbers, and we use it in the gravitational force equation.
Why?
Because if we put it in without scientific notation, it'd be really huge or very small, and that'd be a problem. So scientific notation, it changes it to where it could be like 2 point something to the 10th power, the exponent, which would be 5, which would be simplified and make it easier for us to solve it.
Okay. Connor, how can you tell the length of the major axis from the equation of an ellipse without graphing it?
Or attraction, no. Yeah, attraction to our star.
You double the A value or the largest radius.
Bring up an equation of an ellipse. Oh, they're very small.
Yeah, they're really small.
So point out an equation and show me which one is the major.
The major axis should be this right here, 250 squared.
Okay.
I don't really know why.
Stephen, how can you find the center of an ellipse without any additional points?
Divide the diameter by 2.
Okay, Michael, how can you determine the C value given the center and the foci of an ellipse? You know the center and the foci on that graph. how would you find the C value?
Kind of.
Okay.
Yeah.
My advice to you is, it's gonna kill your telecom because your eye contact is not great, and you're using up a lot of your question time shuffling through the pages. So yes, you're allowed to use it, but I don't recommend it because it's not working out. Because I think you're making it more of a filing problem than just a presentation.
Okay, I am Rashad Muhammad,
I am Zach Garcia.
and unfortunately Sean isn't here today, so we're just gonna go on without him. And this is my little galaxy. We created our own solar system, made with a star and planets and everything. And we're supposed to have 3 planets, one outside the habitable zone. The habitable zone is basically where planets can create life. You can see this picture right here. These two, it's hard to see, but these two dotted lines. This is the outer radii and this is the inner radii. So inside here is basically temperatures between 0 and 100 degrees Celsius, and that's where usually planets develop life.
This is our star. We sent a robot from this planet, Earth, light years and light years away to observe this solar system. And so far we found out that star is very similar to the star we have here, and that it has the ability to support life, and it has quite a few more years to live. Like, it's not going to explode anytime soon.
This is one of the planets that we named. We called it Glaceon.
It is this planet right here. Far out of the habitable zone, it can't really support life.
Yes. So the story that we made for this planet was that it used to be a fully habitable zone.
This planet was in the habitable zone, and space junk or something had struck it, knocked it out of orbit, and it froze completely, and it lost all life, and it just became a frozen chunk of rock.
Right here is our report here. If any of you guys want to look at everything, you can go over to.
And this gives all the data on the planet Glaceon.
As you can see, it's the furthest away from our sun. Sun's that tiny dot right there.
How does mass and distance affect the gravitational force between two objects?
Okay, so for mass, the more mass you have, the greater gravitational force you have. Say if you double the mass of one object and you leave the other one the same, it will double the gravitational force.
And for distance, it's the further apart, the less force they have on each other. So if you double the distance, you're basically cutting the force in half.
Okay, how can you determine which axis is major and which axis is minor?
How you can tell is that, let's say you have an ellipse right here. Let's just take Glaceon for an example. The major radius is where it's centered. The major radius is the one further away, and the minor radius is the one closer to the center. Yeah, that's basically how you can tell major from minor. Major's the bigger one, minor's the smaller one.
Awesome.
Y'all did great.
Thank you.
Gabby, what is a habitable zone, and use your definition of the habitable zone to explain what happens to a planet as it moves through one of the elliptical orbits in your solar system.
A habitable zone is basically to determine if the planet can sustain life and whether the water will be boiling hot or if it will freeze.
So point out just one orbit and tell me what's happening to that planet.
This is our orbit, right? Okay, for example, if our planet were to orbit in this is our habitable zone, the dashed line right here. Right here, it's going to be boiling. So that's really bad because there's not going to be much water. support life. And then out here, it's outside of the habitable zone, and that will keep the water free.
Provide at least 2 characteristics of habitable planets and explain why these support life. 2 characteristics of habitable planets.
So for plants to be able to support life, the temperature on the habitable zones is very important. So
So why is that important?
because the plant needs to have.
It's what scientists use to handle very large.
What are the temperatures in habitable zones?
An example would be like, say, 500.
Do you know? Alexis, which of your planets experiences the greatest gravitational attraction to your star? Explain why this force is the greatest.
The greatest one would be our planet Gemini.
Why?
Because it has the smallest distance from the star. And the shorter the distance, the stronger the gravitational force is.
Okay.
One example of that, this is Gemini.
Okay. Raya, what is scientific notation? And give an example of a problem that's easier to solve using scientific notation.
The scientific notation, like what is it?
What is it first?
I don't know like how to explain what it is.
Just do your best.
I guess it's like not summarize, but like it shortens numbers down as if there was a decimal to exponent or power to something. Okay, and an example would be
It would be negative 3 for this stuff.
this, I guess, the solution due to gravity, and we use this equation, and we got this.
So why is it easier to solve that problem when the numbers aren't scientific notation?
When they are,
Say an object
makes
the mass, if it's increased, then the
it simplifies base.
also increase its distance and increase the gravitational force.
Gabby, how can you tell the length of the major radius of a graphed ellipse without any additional points?
The major?
Yeah.
Well, first you have to determine what, okay, so basically you can use like Pythagorean theorem where you use the center point and then the length from the point to the line. I don't know how to explain this.
Major or minor?
You're asking for major radius?
Yeah, how can you tell, on a graph, without any additional points, how can you tell the length of the major radius?
Depending on how wide or tall it is,
You can go from, say, like the center point.
Oh,
You define the center point and count. Sometimes you can count over to how the edge of the edge of the ellipse.
okay. I'm moving on. You got some practice with algebra too. I wasn't grading you on that. You did pretty good on physics. Cruz. Provide at least 2 characteristics of stars that might have habitable planets. Explain why these characteristics support life.
Lots of metals, because if you don't have metals, then how are you going to survive?
Okay, that's why.
And the speed, the velocity around about the orbiting thing. If it's super fast, then it won't be as go too fast, so you wouldn't really survive that either.
Okay. I'm not sure. I'll have to look at that article.
Okay.
Maya, which of your planets experiences the smallest gravitational attraction to your star? Explain why this force is the smallest. Yes.
That would be Unicornicus.
Unicornicus? Okay, show me on the picture which one that was and explain why that one had the smallest.
It would be Unicornicus because it's furthest away from the star, so it's slower and it doesn't have as much traction towards the star. So.
Okay. Brianne, explain how you use scientific notation to find the gravitational force between your star and one of your planets.
How we use scientific notation? Okay. So we had our mass of our planet and our star, and we plugged that into the universal formula to find gravitational force. And we had to use
We use scientific notation because it's a lot easier to work with than having really, really big numbers. And so we just used it like that.
Do you have the calculation in these slides somewhere?
We don't have the calculations.
You can bring up the report. So give me some of the steps that you're going to have to do. Yeah, give me some of the major steps, like broad picture you'd have to do if you have this in science.
Okay, so this is the formula for gravitational force. We plugged in our masses and then our distance divided by our distance squared. And so we grouped like terms, so we put not the exponents, exponents, those on one side, and then the actual numbers on one side to make it easier for us. And then we added up the exponents, and then since we had a number greater than 1 through 10, we had to use scientific notation in our last step to move it over to make it 1 through 10, to fit into like what is needed for scientific notation.
Okay. First, I'll ask you one more physics question. How do mass and distance affect the gravitational force between two objects?
It decreases as well.
Why?
Because if it's further, then the gravity is closer to this side than it is to the other side.
In your own words, define the differences between circles and ovals.
A circle has a constant radius and an oval does not.
Dosa, first question. How can you determine the foci of an ellipse given the center and c value in a horizontal ellipse?
You would solve for b and you would add it to x.
How would you solve for b given the center and c value?
Connor?
The C value is the distance between the origin point and the focal point. So how would you find that? Okay, so the C value is between the origin. All right, well, the origin, I mean the center of the ellipse, and from there to the focal point. That's the C.
Okay, so would you solve for a and then add for x?
Okay, full help.
What?
Do you want to finish the explanation?
Yeah.
And it's a horizontal ellipse.
Horizontal? Yeah. Alright, well what you would do is once you have the C value, what you would do is you would just take the center point of the ellipse. For example, here it's a little bit over the origin point. And what you would do is you would plus or minus it considering which way it's facing.
Okay, so if you're finding both of them, what do you add or subtract it from?
You add the C value to find the rightmost, and then subtract
Or what do you add it to or subtract it from?
Like if your center was the origin, and say your C was 10, then you would plus, you would add 10 to that, and that would be your focal point.
So what would that new focal point be?
That would be 10, 0.
Connor's first question. Given a focal point, center, and major radius, how many ellipses can be formed and why? Why?
Okay,
You can form more than one because there's no minor radius, so it could be like the minor radius is
okay, so
specified, so it
basically
could be
you
more
just
than
plug in your
one.
numbers and then you separate
They kind of get bigger than the
numbers
major
from
radius.
10 to the power of whatever.
Okay, thank you.
When you decrease the mass, then the gravitational force becomes weaker. And distance is if the distance between the planet and the sun increases, then the gravitational force becomes weaker, but if the planet moves closer to the sun, then the gravitational force becomes stronger.
Naima, explain how you use scientific notation to find the gravitational force between your star and one of your planets.
Okay, so we had G, and that's 6.67 times 10 to the negative 11. And we had the mass of our star. Let's say we use the green star. We use 1.45 times 10 to the 22nd power. And so then we had to divide, and we had the distance underneath squared. And so we divided those up by the base 10 numbers, and the whole numbers, like 6.67 and 1.45, multiplied those. And we use scientific notation or exponent form to add and subtract those exponents. And then we got a number in scientific notation after we did that.
Okay. Give me at least 2 characteristics of habitable planets and explain why these support life.
Okay. The temperature of the planet needs to be not too hot or not too cold.
What's too hot and what's too cold?
Too hot is boiling point. Too cold is freezing point.
Why is that important?
Because a person or plants can't live in too hot environment or too cold environments because they'll either freeze.
Can I give her a hint?
Yeah.
The water will freeze
Okay.
or
That's one characteristic. Give me one more.
yeah. And then the atmosphere of the planet has to be approximately one.
One what?
One atmosphere.
Why is that important?
Because if the pressure is too low, it's too hard to breathe.
How can you tell the length of the major radius from the equation of an ellipse without graphing it?
The major radius is the longer radius.
So for example, if you look at that top equation, how can you tell which one is the major radius? So you're just looking at this equation, for example. How can you tell what the major radius is in this equation?
The major radius would be this.
Why?
Because that's r squared and that's the radius. I don't know.
Team assistance?
I think it would be either. I don't know. I'm debating on between these.
Alexis?
So if you look at it, the original equation is k plus or minus b squared, and b squared is your minor radius, and then a squared is your major radius. So if you have two a's and you add them together, that gives you your that gives you your diameter, but your radius is just a, which is say like this one at the bottom.
Okay, second question. Mariah, how can you determine the foci of an ellipse given the center and c value in a horizontal ellipse? It's the second from the bottom.
You do a squared plus c squared equals b. No.
You just have the center and the c value.
If I just have the center, I don't know.
Team assistance?
I thought that.
Read the question again.
How can you determine the foci of an ellipse given the center and c value in a horizontal ellipse?
Given the center and the c value. So you have the center of the horizontal ellipse. So if you take your c and you plug it into a squared equals b squared.
Nope, you don't know your a and your b.
You don't?
You just know the center and the c value.
You know the center and the c value, and you're trying to find what?
Your foci.
Your foci.
It's a horizontal ellipse, so what are you adding and subtracting to?
Horizontal. You're adding and subtracting the x's of
The center point.
yeah, the center, your center and your c. Add and subtract. That way you get both your focal points.
Okay, thank you.
And what is a habitable zone? And use your definition of the habitable zone to explain what happens to a planet as it moves through one of the elliptical orbits in the solar system.
Okay, so the habitable zone is basically the zone where the planet is going to fully always sustain life. In our planet, the red planet is the one that is always in the habitable zone. As the other two planets, such as the blue planet can sustain life for a short period of time because it's mostly outside of the habitable zone, while the green planet is always outside of the habitable zone, meaning it will never support life.
How can you tell the length of the major axis from the equation of an ellipse without graphing it?
So if it's horizontal, you can look at the A value and that'll give you the major, and if it's vertical, you can look at the B value, which will give you your major.
Okay, provide at least 2 characteristics of stars that might have habitable zones.
Okay, well, a star to have habitable zones for the planet, it has to be at least 39 years old, and it has to have at least a mass of 0.5 to 1.48.
Alright, back to Martin. I just asked you physics, right?
Yes.
Alright, so we'll do algebra 2 for right now. In your own words, define the differences between circles and ovals.
Okay, so a circle always has the equal distance from the center to any of the sides, and an oval doesn't. An oval, like, let's say the blue one, it has the shorter distance between the center if you're going to the horizontal, but if you're going vertical, it has a greater distance, and that's what makes it an oval.
Alright, nice.
Okay, what is the scientific notation? Give an example of a problem that is easier to solve using scientific notation.
Okay, so scientific notation is a way of writing numbers that accommodate for numbers that are inconveniently small or inconveniently large, such as the mass of our planets. The masses of our planets are very large, so the mass of planet Venus is 6.2 times 10 to the 24th. However, if we were not to write it like that, we would have to put 6.2 and then 24 zeros.
Okay, what does B represent?
B in a horizontal equation, it represents the minor radius, and in a vertical equation, it will represent the major radius.
Okay. How can you determine the foci of an ellipse given the center and the C value in a horizontal ellipse? Second to the last.
Alright, so for a horizontal, the C is the distance between the focal point and the center, so you're going to add the distance to the center point to find the one focal point, and then you're going to find the opposite from the other side.
Okay.
How can you determine the
need of physics.
of an foci of an
Okay.
ellipse given the center and C value in a horizontal ellipse?
So C is the distance between the focal point and the center point. So what you can do is for the vertical, because it gives you that, it's going to be the major radius that it's giving you. So with the major radius, to determine the C value, you know, that is, the major radius will be your B value. So you do B squared plus C squared. And your major radius is going to be whatever it was from the center point to the outside of the horizontal axis, which is the x-axis, and that will give you your C.
Okay. What does A represent?
A represents the major axis with the horizontal and the minor axis with the vertical.
Danny, first question. How can you tell the length of a minor axis of a graphed ellipse without any additional points?
We didn't get your, if you're doing a vertical, you get your y1 and y2, subtract them so you get your center point. And the same thing goes for a horizontal.
So you subtract them and that gives you your minor, I think I asked you about, oops. I think I asked you about the minor axis. Yes, okay. Alan, first question.
Yeah.
Okay, so as you can see on this map, this is
How can you tell the length of the major radius from the equation of an ellipse without graphing it?
You said major radius?
Yes.
Alright, so you're going to take your A value and your B value, and you're going to
I'll use this planet for
multiply
example.
by 2.
This planet is called and whenever it moves, it's half in. Is it really
It's going to be your A value.
what is the relationship between
Always?
whenever
Always?
on it, but you can't sustain life? It's not always.
Yes.
Whenever it comes to the inside of it.
That's not completely correct.
It's not too close to the star. And it has
Okay, Akil. First question. How can you determine the foci of an ellipse given the center and C value in a horizontal ellipse? First team, do you want to assist him then?
I would love to assist him.
So if you look at the graph,
You have the center and
here,
C, right?
this is the
You have the center and the C, yes.
And if you
Great.
know what
Okay, so
here and there, then you can subtract the y-axis. You can subtract it to add it together and then average them, and that'll give you the center point. And that you can take the y-coordinate from the center point and subtract it. Or you can. So is the closest point always the one that experiences the greatest gravitational force?
we're supposed to
Oh, no.
Also, let's give it the center.
take the
Thank you.
the radius of C and stop. And then we add them together, and that should or subtract them, and that should give us
Second question for Danny. Given a center, major radius, and point at the end of the major radius, how many ellipses can be formed and why? So again, you have a center, a major radius length, and a point at the end of the major radius. How many ellipses can be
So
formed?
what if you have
and why?
planets that are very far away and big mass compared to planets that are
What is a Hubble zone? Use your definition of the Hubble zone. Explain what happens to a planet as it moves through one of the elliptical orbits in your solar system.
Hubble zone is a place that can sustain water in between, or like that's the one place that it wouldn't be, it wouldn't, any closer it would be too hot to, it would just evaporate, and it wouldn't be able to, it would freeze. And what was the second part?
Pick an orbit and tell me what's going to happen to that planet. Just gives it where it's at.
This orbit is Janet, and it's in the habitable zone, and because of that, it is able to hold water and sustain life.
Okay, next question.
Ashley, how can you tell length of a minor axis of a graph ellipse without any additional points?
Wait, what question is that?
How can you tell the length of
No,
a...
like on the paper.
Oh,
It's hard to say. Just listen carefully.
5. Good question.
1, 2, 3, 4, 5. How can you tell the length of a major axis in equation on the ellipse without every net? If you look at the equation, there's going to be two numbers, and for the major axis is the number that is bigger in that equation.
Which two numbers are you talking about?
Sorry. It's going to be like for this one, it's going to be this number and that number, so it would be the one who's larger, which would be 182.5.
Casey, how does the acceleration due to gravity on one of your planets compare to the acceleration due to gravity on Earth? Explain why this gravitational acceleration is larger or smaller.
Okay, so on our planet, Janet, the one that sustains life, that is in the habitable zone, so we assume it can sustain life, there the gravitational force is 4 times greater. Can you repeat the question?
What was the acceleration due to gravity on Janet?
4.44, which is 4 times, it's just about 4 times bigger than the gravity on Earth. So
What's gravity on Earth? The acceleration due to gravity on Earth.
Not 9.8.
Yes.
9.8. So it's about 4 times greater.
Oh, you said it's 44. Go. Continue. Okay.
And so things on our planet Janet would weigh 4 times more.
Okay. The second half of that question is why is that one bigger?
It's bigger because, as you can see here, our planet weighs more, and I'm not sure of the radius of Earth, but I assume it has a bigger radius as well.
Next question.
What is H?
H is the x value of the center point of an oval or a circle.
Which of your planets experiences the greatest gravitational attraction to your star, and why is it the greatest?
What is it? It is granite because it is closer to it is pomegranate because the mass is greater, and we have a greater mass. You have a greater gravitational.
Which one is pomegranate?
The outer one. Whenever you're farthest away, you have
The most gravity force?
Yes. No, opposite. Sorry. No.
So
it would
your
actually
bearings,
it would actually be granite because it's the closer you are, the most gravitational force has. It's the opposite. It's the mass. Whenever you have the more mass, it's when you have
more questions.
How can you determine which axis is major and which axis is minor in a graph ellipse?
The major radius is the number, no, it's the bigger number, in the 2. So, yeah. Okay, see how this number is bigger than that one? That would be it.
Okay, first question is for Ashley. How can you tell the length of the major radius of a graphed ellipse without any additional points?
You would count from one end of the oval to the other end and divide that by 2.
How do you know that that's the major radius?
Because the major radius is the diameter. Because the major radius is it's B in the equation.
You don't have the equation, you just have a graphed ellipse.
Okay, well, so do we have the equation?
No.
Can you repeat the question again?
How can you tell the length of the major radius of a graphed ellipse without any additional points?
You can see which one is larger, and then using that, you can find the point. If you know the point there and the one there, then you can average them to find the center point, and then subtract the x value of the center point.
Okay, so you count the diameter from both sides, and you subtract that value by then you find your middle point, and then you subtract that x value of the middle point out of the radius.
Stella, first question. How can you determine the C value given the center and foci of an ellipse in a horizontal ellipse? It's fourth from the bottom on the front page.
It is, how can you determine the C value given the center point? The center and foci of an ellipse, right?
Yes, in a horizontal ellipse.
Okay. Let me read it again. Summarizing a number, a really long number. You count the number of units between the coordinates on the x-axis.
Okay. Casey, first question. Given a center, major radius, and point at the end of the major radius, how many ellipses can be formed and why?
Well, depending on whether you can form any ellipse you want, if you can do that, it can be infinite because you don't know the focal point. So the focal point could be pretty much anywhere, giving you an infinite number of different ellipses that could be formed. But if you're only allowed to use the information that was given and you weren't allowed to make things up, then you couldn't form any.
How can you determine the foci of an ellipse given the center and C value in a horizontal ellipse? Second to last on the first page.
So you would
Because it is a horizontal ellipse, you would subtract from the add or subtract from the x value.
Add or subtract what?
When you would add or subtract from the c value that you were given.
Given a focal point, center, and major radius, how many ellipses can be formed and why?
Okay. One, because you know all the necessary information to create the one ellipse.
And there's no others that can be formed?
You don't have any other information yet.
Just from that, are there other ones that can be formed?
With just the...
So you know a focal point, a center, and a major radius. Can you form other ones? Is it possible?
No.
Why?
Because you only have the information, you don't have anything else.
No, if you can change other information, so just based on that, if you can change the other information to be other numbers.
Oh, then yeah. So you can make one other.
How many?
One. If you can only change it once, then you can only change it
No, you have a focal point, a center, and a major radius. That information is set. That's not going to change. Everything else about the ellipse can be determined or can be invented. How many ellipses can be formed from the focal point, center, and major radius that's given?
One.
Okay, why?
Because you only have that information. You can't make anything else. You only have the information for one set, not multiple.
Okay, thank you.